There are 8 variables to coffee brewing. We're gonna hit on each one of them real quick, and then we're gonna split them up into 3 categories, which are quality, ratio differences, and grind size, and the 3 keys to brewing. The 8 variables of coffee brewing are 1, the quality of your water, 2, the quality of your coffee, 3, grind size, 4, the amount of water you're using, 5, the amount of coffee that you're using, 6, the amount of time that you're brewing for, 7, the temperature at which you're brewing your coffee, and then 8, the action or the pressure, whether you're stirring or applying pressure to your coffee. Those are the 8 variables that, when you understand how they work together and what impact each one of them has on your cup, you can simplify into a simple recipe for brewing coffee and learn how to make really good coffee and improve really good coffee. All 8 of the variables that we've listed are going to be attached for you, as well as the 7 pieces of equipment that you need and a lot more material that we're going to cover. We are going to talk about coffee quality and water quality. First up, we're going to talk about coffee quality. So let's dive in. Coffee quality is so important, and that's clear, I think, because we're coffee shops. We're running and selling and brewing coffee all day long. So what we're looking at when we're talking about coffee is super important. What I mean by coffee quality, however, is your coffee perfectly roasted? That's not a thing. Roast is an important factor, crucial factor in the coffee process, because you're taking a green seed and you're cooking it to a certain degree of cookedness from a certain place with certain flavor characteristics and all that. It's super important to know what the coffee that you're getting is. But every single coffee is different from every single place that you get it from. If you're getting coffees from places like if you're getting coffee from places like Kenya or Ethiopia, those are going to have often very floral or very fruity notes naturally in them that can be super good, but also highly acidic. So they're not always the best for espressos, but they're really good maybe on pour over or drip coffee. However, on the flip side, often coffees brewed in Central or Southern America can have very chocolatey, nut forward flavors. That's a very broad generalization. Every coffee can vary, but that is a distinguishing factor that can help you think, okay, I'm looking for a coffee for drip for every person that comes in the shop, or I'm looking for a coffee that is a baseline for my espresso. So that's where we developed on our end what we call the Spro blend, the espresso blend, and it's designed for espresso machines to pair well for every consumer that comes in, every customer that comes in and tries it. But it's balanced. It's going to have a lot of chocolatiness, a lot of nuttiness, a little bit of sweetness, but nothing too crazy. It's designed to pair well with milk and this and that and the other. It's a more, what you might call a more medium roast or a little more traditional style, but a little on the lighter side. It's super important to distinguish. When you're looking at coffee, some of the questions that you can kind of ask are, is this more modern or more traditional? What I mean by that is this a very light, fruit forward, maybe highly acidic roast that people that are maybe more into pour overs and more into some really fun, or really unique coffees would like? Or is this something that's a little bit more dark, a little bit more mild, has some smokiness to it, tastes more like the coffee that I grew up with? This is going to pair better for a lot of the generation that is used to the classic Folgers in the morning, this, that, and the other. Knowing the people that are coming into your shop, knowing the people, that the palates that they have and what they enjoy is going to be super crucial for what you order and what you get. There's no perfect roast, there's no perfect cup of coffee, but it's super important to know that you're getting the right coffee for your people. So we could talk about this for hours, and it's super, super valuable to keep learning about that. We're going to attach a little bit more information about how to determine what you're tasting and what your coffees are that you're buying. But also, if you just want to reach out, we can always work with you. If you're ordering our coffees especially, we can work with you on what you're getting, what this coffee is going to be like, who it's going to work well with. And at the end of the day, it's a learning curve. Try out coffees, have fun, taste a bunch of different things, make mistakes, have a blast. Try coffees that are not in your neighborhood, that are not in your wheelhouse. Try coffees that are. Compare and contrast and get to know different things and have some fun. But at the end of the day, know your coffee, know your people, and seek to serve them best. And then comes water quality. Water quality is super important, nearly as important as the quality of your coffee. For today's example, we're going to use Dasani water. Now, the reason that we're using Dasani is because it has minerals added back into the water. Essentially, the water was treated, a lot of the minerals were stripped out of the water, and then they added minerals back into it for taste, is what they say on their product. The reason that Dasani is a good example is because you don't want to use water that has nothing in it. One time I bought an espresso machine for a weekend event. It was the first espresso machine I ever owned, actually, and it was this little Victoria Arduino machine, and it was this little Victoria Arduino machine, and it had a water tank on the back. And so I went and bought a bunch of distilled water thinking, good, this is super purified water. It'll be great for coffee, good quality. And I poured it in the back of the machine. And then when I turned the machine on, it said no water. And it was giving me a blinker that was telling me that there's no water in the machine. And as I looked in the back of the machine, there was clearly water in the machine. I didn't understand what was going on. This machine in particular would send sensors or pulses through the water that would bounce back and tell the machine that when there was water in it and when there wasn't. But since there was no minerals in the water, it couldn't even detect that there was water in it, which led me on this whole journey of like, why would a machine not work with distilled water? And it's actually a very good feature that that machine had, because distilled water, like I just mentioned, has no mineral content in it. Just about everything has been stripped out of the water. It's down to its base. It's just H2O. And that's cool. That's great. But a lack of minerals implies and means a lack of flavor. So whenever you're brewing coffee with distilled water, you're not going to get nearly as much flavor out of that coffee. It doesn't have minerals to latch onto. It doesn't brew as well. However, if you're using a water that has minerals added back to it, or simply hasn't had all of its minerals stripped, if you get a good spring water, that can also work great for brewing coffee. On the flip side of distilled, you might run into very hard water, or if water has a lot of material in it, if there's a lot of chlorine in your water, or a lot of lead in your water. Okay, not lead. Hope there's not lead in your water. My goodness. Wrong word. If there's a lot of chlorine in your water, or if there's a lot of fluoride in your water that you're to the point where it affects the taste, it may make your coffee taste quite different. And so filtered water is going to be very important for coffee brewing in most areas. Depending on where you live, your tap water may taste great, but if you're like me, you might need to filter your tap water for your coffee quality. And especially in a coffee shop, you're going to need some sort of filtration to improve the quality of your coffee and the consistency. So if you have city water like I do, they are putting chemicals in seasonally and at different times that changes the flavor. The flavor of the water fluctuates. It also just has a lot more harsh products in the water that shows up in the cup. At my house, it creates a muddier cup. So for you, that may or may not be the case, but allowing some sort of filtration is incredibly helpful, especially at your cafe. So for at home, I will just use a Brita filter. It works great for me. It does the job with the type of water that I have. But what I sometimes will do if I'm looking for something a little more put together is maybe I'll buy some Dasani. I don't always choose that. It is a little bit wasteful to grab a water bottle every time that you're brewing coffee, especially if you brew it every day. But Dasani is good because it's a set mineral content. It's not too many minerals. Another option with your water is you can grab distilled water. And then what you can do from there is you can grab something like third wave water. What third wave water is, and there are other companies out there that do that, we'll link a couple, are packets of water that for this packet, for example, you would take a gallon of distilled water, no minerals. That's the point of the distilled water, no minerals left. And then you add this packet back to your water. It adds a very set mineral content. And this company has worked to make a mineral content that is well designed for brewing coffee well. It's not for everyone. They have a couple different kinds. In our shop, we don't actually use third wave water. It doesn't give us the exact flavor profile that we're going for, but we're also being pretty particular. It's totally up to you. You may taste it and absolutely love it. I think it's really good stuff and I totally recommend it. It's also just a little bit more expensive than using a classic filtration system because you're buying these packets. So it depends on what you do, how economical you're trying to be. But those are kind of your three options. You've got your classic filtered water, you've got your water bottle or some sort of spring water, and your distilled water with, or really filtered water with something added back into it. At the end of the day, the quality of the water that you're brewing with is super important. So what I would say as a recommendation across the board is just say no to using tap water in your cafe and buy some sort of filtration system. I wouldn't suggest a Brita for a cafe. You're gonna want some sort of inline system that filters the water before it gets to all the places that it's going to go. You could either attach one to that is going just for your espresso machine, which will need some sort of filtration, also just so that no sediment gets into your espresso machine. If you don't have that set up, I would totally check into that. Most espresso machine most espresso machines require some sort of inline filtration to protect the machine for pieces that get in, but not all, but I highly recommend it. But additionally, you might have filtered water that's going to your drip brewer. It depends on your budget and the design and layout of your space. Totally understand that. But I recommend getting some sort of filtration for your shop. That's a wrap on quality though. So if you've gotten your coffee figured out and you got your water figured out, you have done 2 of 8 very important things to have good coffee. Once you get your coffees figured out, like this brewski blend, for example, that we use for our cold brews, shameless plug. And once you get your water figured out, something like a filtered water, a Dasani, whatever it is, those can pretty much stay the same. Once you've figured out those 2 variables, you're not gonna have to mess with them nearly as often. Now, seasonally, coffees might change. You may have to get a different coffee as one fades out, as a new season comes. But for the most part, deciding on your coffees and deciding on your waters, those variables are gonna stay the same and you don't have to think about them again. The other 6, on the other hand, are variables that are changing a little bit more dynamically and you have to be paying a little bit more attention to with each cup of coffee that you brew. While 6 may feel like a lot, before long they will become common sense. While 6 may feel like a lot, before long they'll become basically common sense for you. You won't have to think about grind size nearly as much. It'll just be understandable and simple. But for now, to define all 6 will be super helpful. So let's go ahead and keep going. We're gonna go straight into ratio and grind size. So now we're gonna talk about ratio differences and grind size. So first off, diving into ratio differences. When I say ratio, I mean the amount of coffee to the amount of water. So let's say we put 1 gram of coffee in a cup like this. I'm just gonna do 1 little gram. And then we do 16 grams of water in that same cup, which is a very small amount of water. I poured a little more than that on accident, but let's say we did 1 gram of coffee to 16 grams of water, and then we let that sit. That is a 1:16 ratio because there's 1 part coffee to 16 parts water. Now, if we were to expand that, that would be a very standard ratio for a lot of different methods of coffee that you would work from. We'll attach a sheet that gives a couple different examples of some standard ratios, some ratios which you can build off of for different brewing methods. So if you're brewing espresso, it's gonna have a classic 1:2 ratio, but we're gonna give an example like 18 grams of coffee to 36 grams of water output in your cup. And for drip, another recipe, another ratio, and another and another. And the reason for that is to give you somewhere to start so that you can really dial in your own coffee. But now let's equip you to dial in your own coffee. So ratio, how does ratio work? Ratio is essentially determining the potency of your coffee in your cup. So if I were to fill this little guy all the way up with coffee and then pour water in until it was full, I would have a ton of coffee to a very small amount of water. And that'd be a very potent cup. Espresso is a much more potent cup because you have about 1 part coffee to 2 parts water. And then it's put under a lot of pressure and you get a very strong tasting drink, a very potent cup. But drip coffee is much more smooth, more enjoyable. More people drink drip coffee every day than drink espresso, at least in most places in the United States. So for example, with drip, you would have maybe 1 part coffee to 16 parts water. And it's a much more diluted, but flavorful drink. Now later we're going to talk about how you take that diluted drink but still get a full flavor from it, because you can have a smaller portion and still a full extraction of the flavor. But we'll dive into that later as we get further along in the course. That's super helpful to understand for all the brew methods and how they work together, but we'll get there. For now, the important thing to note is pay attention to your ratio. A good place to start with drip is 1:16. If you would like to make your drip stronger and you find that, or more potent, and you find that the people that are coming to your shop are saying the drip coffee is just kind of weak, I want more flavor. Now one, it could be your brewer, check that out, make sure everything's functioning correctly. Make sure your grind size, which we're about to touch on, is adjusted well, that the grind size is good and is going to bring a good extraction. But if you've checked that, if you check the brewer and check the grind size, something to consider is your ratio. So for a second, let's just take a moment and talk about how we adjust ratio if something's off base or we want to get something more dialed in. Just pay attention. If you're audience likes a stronger cup, or a cup that is the coffee is more present in. You may think about dialing your ratio and making it a little more intense. So instead of a classic 1:16 for drip, you find your audience typically comes in and wants something a little stronger or a little more potent, a little more concentrated. Then try a 1:15 ratio and work from there. But really, ratio at the end of the day is just the amount of water and the amount of coffee. And you can kind of figure that out for each piece of equipment, for espresso, for drip. And then once you've got that locked in, you've got it locked in. You don't have to think about it too much more. Once you know that people coming in like drip at this ratio, then you just write your recipe down. If it's a pot of coffee, if it's a liter pot, then you just calculate that out. Say it's 1,000 grams, take it, divide it by 15. That's how much coffee you put in if it's a 1:15 ratio, that kind of thing. So you get those set, and then those are set in place. So those two variables are covered. So at this point, we've got quality covered. We've got the quality of your coffee. You've got the quality of your water. Now we've got ratio, so the amount of coffee and the amount of water. And really, once you get those four worked out, while there can be some variability, those can kind of be set more in stone. And once they're set in stone, you don't have to worry about them every time you're doing a cup. You can kind of set them down. You have to think about them a little bit. If you're doing espresso, you're not going to brew it the same way as drip. But for the most part, you can kind of set them down and say, okay, now these are in place. We know what we're doing. There's 4 variables left that I have to think about. These 4 are going to be grind size, which we're going to hit now, and then the last 3, which are the 3 keys to brewing, which is time, temperature, and action or pressure. We'll get to those in a moment. So let's go ahead and dive into grind size. So for grind size, we're going to do a little bit of an example where we're going to toss out a bunch of different grinds for different brew methods and just kind of show them side by side what it can look like. And then we're going to talk about how grind size affects extraction, and how once you know your ratios and you have your coffee and your water picked out, you can start to think about those things less and focus more on grind size and time, temperature, and action. So let's grind up some coffee in some different ways and some different sizes and talk about what we're looking at. So we're just going to start very fine and increment up from there. So here's a very fine grind, a little bit more like a fine sand. Here's a little bit coarser, but still pretty fine. It's a 12 on the Encore or the Brazza Virtuoso. This might be the finer side of what you would use for like a pour over. Whereas the finest is closer to an espresso, but on this grinder, still not quite as fine as you'd go for espresso. So there's this one. We're just gonna keep incrementing up. So now we're getting a little bit coarser, but I would still call this a fine to coarse grind. You're somewhere in the middle now. You're getting a little bit of bigger chunks, but for the most part, this is going to be a little bit coarser than you're going to use on your average pour over, but you might use this for a Chemex or even a little coarser for a Chemex. This is a 16 on the Virtuoso, but we're just going to keep increasing. The next one's going to be a 22 on the Virtuoso. Just going for some big jumps here. At this point, the last one was a lot more like sea salt. We're going to be crossing that line, getting to bigger chunks, more like flakes of salt, if you will. This is a grind size that was probably a little bit coarser than you would use for a French press, but right around a French press, somewhere it would be somewhere between these two. This might be a grind size you'd start to use for something like cold brew. And the last one we just did in the 30 range, 30 to 40, I was kind of moving it. And this is a grind size we would not use in most scenarios, but it is big chunks. And it's still valuable to pay attention to. And then finally, last but not least, is no grind, but still small pieces here. So this is kind of a range here where we can see it going from really coarse, as you would call it, This would be the fine side. If this was a scale, it would be fine on this end, coarse on this end. So here's completely coarse as it can get. These beans aren't even cracked open. They're just whole beans. Start to grind it a little bit coarser, which is where the burr grinder really comes in handy. We can control consistently what we're looking at. A little coarser, or coarse ground, a little finer, finer, and then the finest. So we could keep going finer than this. The only things that get about this fine, which is about as fine as sand, if not finer, is espresso. And then if you're doing something like a traditional, maybe a Cuban coffee or a Turkish coffee especially. Turkish coffee can be even finer than espresso. If you're doing that in your shop though, I suspect you'll be doing a lot of research anyway on how to do that, or you may already know how to do it. So we won't dive too deep into Turkish coffee, but that would be more on this end either way. But here's kind of your array of things. And you notice I was mentioning different brew methods as we were going through. I was kind of talking about how this one would be good for this and this one would be good for that. And I think that starts to lead to some questions like, why would a French press use this grind and a cold brew use this grind, but a pour over wouldn't? And a Chemex pour over might use this, and a V60 pour over might use this. So just to illustrate what I'm saying, a Chemex is this guy, V60 is this guy, a French press is this guy. Cold brew can be brewed in just about anything, but let's use, for this example, a jar. It's got a little bit of coffee in it. But you could brew cold brew in a jar or anything bigger, but it wouldn't be this grind, it'd be still this grind, but cold brew for that example. And then we'll bring out an espresso machine later, but it takes a lot of space, so we'll leave it off the table for now. But imagine there's a huge espresso machine right here. So this is kind of the example of what we're looking at. So what we want to talk about, and this is going to actually end up being tied into the 3 keys to brewing, but for now, we're just going to talk about a little bit more is what's going on with the grind size. Why are we focused on different grind sizes for different brew methods? Why does that matter, and how does that affect our cup? So let's illustrate. We're going to brew 2 different coffees, and we're going to talk about the grind size and what's going on. So I'm going to brew it with water that's at 200 degrees Fahrenheit or about 93 degrees Celsius, and we are going to brew some coffee. So something to think about as we start doing this is imagine taking this bean and pouring hot water over it. If you do that, nothing's really going to happen. It's not going to dissolve. It hasn't been broken up into small enough pieces. Water's just going to run over it. And it would take a very, very, very long time to break this up to where it would dissolve just by pouring hot water over it. But that's why we grind coffee, right? So we grind it up super fine. As you can imagine, if I poured hot water over this, it's not going to take nearly as long to dissolve as that, because actually, and this sounds almost counterintuitive, but this has a greater surface area than that does, because by breaking it open, we've exposed more surfaces to the air, to the elements, to water. So when we pour boiling water over super fine coffee, it extracts super fast. So whenever we're brewing coffee, we're always playing the game of the finer the grind, the quicker and more easily it extracts. The hotter the water, the more it gets action, the turbulence or the stirring or the agitation of the beans, the pressure even with espresso. And the longer that it brews, the more it extracts, up to a certain point. That's the game that we're playing. So to illustrate that, we're going to brew a French press, and we're going to brew a pour over a V60. And we're going to talk about why we're going to use different grind sizes and how we're going to use the different grind sizes to brew a consistently quality cup with a consistent extraction of flavor. We're going to dive more into extraction later, and these two will come together, but keep that in mind for now. So imagine for now we're starting with 0% extraction. Nothing has been extracted, pulled out of the bean yet. And as soon as we start brewing, that percentage starts increasing. The bean starts dissolving, extracting into the cup. So let's start doing this. A little tip, a little side note, what I'm gonna do with this V60, I'm actually gonna pre-wet the filter. What that's gonna do is get any paper flavor out of the cup, out of the filter, so that whenever we're brewing our coffee, there's no paper taste whenever the people drink the cup. So I'm gonna pre-wet it. It's also gonna allow us to preheat the bottom part of the cup. This is especially helpful in cafes and stuff like that. This is especially helpful in even your cafe, where whenever you pour a cup, what am I saying? This is also going to, By pre-wetting the filter, we're also preheating the cup, which is super helpful. A lot of times whether it's with lattes or whether it's with hot coffee, people that get larger drinks, often the drink will get cold before they can fully drink it. And so preheating the mug or the cup can be really helpful because it reduces the loss of heat in your cup. So this is good to always preheat. It both rinses the filter with the hot water and heats your cup. So I'm gonna go ahead and dump this water and we'll come back. So to kind of dive in, let's go through the 4 things that we've covered up to this point. So quality. What coffee are we bringing to the table and what water are we doing? So for now, we're using Dasani water, which is going to be helpful for just having a good mineral water that we're brewing our coffee with. It's going to be consistent at the very least. So throughout this course, we're just going to use Dasani water for the brewing. So if you wanted to mimic this at home, you could go find Dasani off the shelf and you could brew along with us. For the coffee, today we're going to be using the Spro blend, which is our espresso blend, but it's also just really good to drink. So we're gonna go ahead and brew that for our hot coffees today. So that's the quality of coffee. It's a espresso roast, so it's designed to be paired with milk, but it's a really good just daily drinker as well. It's not too flamboyant, not too crazy. It makes for a good tasting coffee for comparing and trying. And we're gonna use Dasani water for our quality. So the quality section is knocked out. Boom, we've got the quality. Then the ratio, let's talk about the ratio. For this V60, I'm going to do 15 grams of coffee to 250 grams of water. So we'll go ahead and grind that up and get started. So I'm gonna go ahead and toss this on the scale. And I'm just gonna measure out 15 grams. Now that I've got that set, we're gonna go for the French press, and I'm gonna fill it with a much coarser grind. So this grind in this V60 is very akin to this grind right here, or somewhere right between these two. I'm at a 14 on the Virtuoso. And then for the French press, what I'm gonna do just for today, this isn't a, here's the recipe you should do. This is just a recipe for the example. We're gonna do about 31 grams of coffee to 500 grams of water. That's gonna give us a 1:16 ratio. So 31 grams of coffee in. And then we'll do 500 grams of water. So let's start with the V60. There are a million recipes out for how to do pour overs. We're just gonna do a single pour V60. So what that means though, with a V60 is I'm gonna do one pour that is a bloom. I'm gonna let the water saturate the beans, start extracting them, bubble, all that stuff. Let that sit for about 45 seconds, and I'm gonna pour one more pour until we get to 250 grams. So we'll talk more about that, but we'll just go ahead and do that for now. I'm gonna start the timer and get going. While this is going, this is a great moment to talk about the difference between these two methods of brewing. So with a V60 or any pour over or drip brewer or espresso, these kinds of things, what's happening is, we're pouring water on the top and the water is immediately running through the coffee, right? So what helps me when it comes to grind size is to think about a river or a waterfall or something like that. So I'm just gonna go ahead and fill this up to 250 grams and then we're gonna watch it drain. If you're doing lots of pour overs, I absolutely recommend a gooseneck kettle like this one. Gooseneck simply means that it's got this neck right here. It's gonna really help for the consistency of your pouring. I think we said already, but we'll attach a list of kettles that will give you options for what you're looking for. While that's extracting, we're about to get started on the French press, but let's just talk about the difference between these two brew methods for a second. So this is a filter coffee, a drip coffee, a pour over. This is specifically a pour over, but what's going on is the same as what happens in drip or filter coffee. Similar to what happens in espresso, we're putting water over the top of it, and then we're letting that water drain through the coffee. On the flip side, with the French press, what we're gonna do is we're gonna pour the water in there, and the coffee's just gonna sit with the water as long as it's brewing. And then the longer it sits there, the more the flavor extracts. We get more and more flavor in the cup, not always desirable flavor, which is why there is a time limit. We won't brew it forever. And then whenever we're done, we'll pour it out through the filter. So that's a very different brewing experience. This is called immersion. This goes by a bunch of different names, but today we're just gonna call it filter brewing or drip brewing. So now that that V60 is wrapping up, we'll go ahead and do the French press. So like I said, I did 31 grams of coffee in. And we're going to do, I'm gonna reset the timer. That took about 2 minutes and 45 seconds. I'm gonna reset the timer. I'm gonna pour 500 grams in, and we're gonna do about a 6-minute French press. You'll notice I swirled it. With swirling it, I was making sure that all of the beans got saturated. Of course, we'll talk about that more later on, but essentially what I'm making sure happens is that all of the beans get touched by the water within the same few seconds, so they all start extracting at the same times. I'm making sure that there's no pockets where water doesn't touch, so that we have a consistent brew. So once that's bloomed, after about 45 seconds, I'm gonna come back in and pour water in up to 500 grams. Bloom is simply called a bloom because what's going on is it's bubbling and all of the gases are escaping the beans as soon as the water hits them because the water allows the coffee to release the gas. And so when that happens, a lot of bubbling happens, a lot of movement happens in the cup. And if I just start filling it up at that point, especially with like a V60 or a pour over or drip coffee, with those bubbles passing through, the water's just gonna channel down and we're not gonna get a consistent brew. So it's really important to allow it to bubble and bloom before you go in with the next pour and finish your cup. So this French press, we're gonna give it about 4 more minutes. I've got a timer ticking over here. These coffees are brewing. This guy is finished, that one's still going. We got a few minutes left on the V60. I'll set it there for now. Let's talk about the difference between these two. I told you that this guy took about 2 minutes and 45 seconds, and this is gonna take 5 minutes. That's a very big difference. Why? Well, it may be easy just to say, well, this one had more coffee, it needs more time to brew. This one had less coffee, it needs less time to brew. And while there's some truth in that, that's really not why we brew them at different amounts of time. The real difference here is that, the real difference here is in the grind size. So for a French press, we want the water to sit with the coffee and extract the flavor out. But if we were to go super fine, just like with anything that you're mixing into water, the finer it is, the easier it dissolves. With a French press, if we were to pour super hot water over super fine coffee and let it sit for a few minutes, the potential for it to over extract, to be oversaturated will be much higher. So for a French press, we go for a coarser grind, much more like this, much more akin to large chunks of sea salt. We put that in there, and then that way, over time, that coffee has the ability to extract slowly, as opposed to a finer grind, which is gonna extract really rapidly. That's why espresso is a super fine grind, because you're brewing in about 25 seconds. So if you were to put a coarse grind like this into espresso, it wouldn't extract in time. There's too little surface area, too many chunks that are big, that in 30 seconds, that hot water can't dissolve enough of the coffee. But for a V60, we're running the water through the coffee, we're agitating the coffee the whole time, and we want it to travel through at a relatively smooth pace. If I was to make the V60 as coarse as the French press, the water would just run through it super fast. So I need to slow that process down. I need to make sure that the water sits with the coffee long enough to extract it, but not so long that it over extracts and it doesn't run through it so quickly that it under extracts. Our goal is to find that happy medium. We'll talk about why we want that happy medium and what extraction really means in a few. But for now, what we want to hit on is really what's going on right here. Why do we want to slow this down? How do we slow it down? So how do we slow it down? Well, there's something intuitive about a coarser grind is going to allow water to flow through it more smoothly, and a finer grind is going to allow water to flow through it much more slowly. But that can be kind of a tricky concept, and so for me, what has helped me a lot whenever it comes to understanding this and just grasping this really quickly, I think of a waterfall. So imagine you've got a creek above a waterfall and there's huge boulders in the waterfall and the water's running through the boulders. If there's just boulders there before the waterfall, the water's just gonna fly right through the boulders and right off the edge of the waterfall. You're super good. Like the boulders don't stop the water, just allow them to keep moving. But if right before the base of that waterfall, it's just a huge wall of sand. There's just sand completely filling the creek above the waterfall. When that water hits the sand, it's gonna stop and it's gonna start to fill up and dam up because it can't pass through that sand nearly as fast as it can run through boulders or around boulders. Same thing's happening here. French press is the boulders, this is the sand. So what's going on is the water can't pass through the beans as quickly in a V60, so that allows us to slow down the process and allow the water to slowly drain so we get our extraction. Whereas if we would have chosen a coarser grind for the V60, the water would have run through it way too quickly. And if it ran through it way too quickly, we would have had an empty cup. What I mean by that is under extracted. The water would have run through it, but not pulled all the flavor out of the grounds. So we would have had a non-desirable cup of coffee. So we need to slow it down enough that we reach our happy medium. Let's say, for example, that we were to take this cup, this V60 right here, and instead of putting in this grind, we put coffee in at this grind level. Super, super fine like sand. Let's say we filled that cup up with it and we poured water over it to let it drain. Would it drain in 2 minutes and 45 seconds like this cup did? No way. It would probably take closer to 5 minutes. 5 minutes with a grind that fine is gonna extract all the flavor out of these little guys and probably a lot more. And we're gonna get some really over extracted flavors, which we'll talk about, but which means a lot of bitterness in the cup. However, let's say we take that grind and we throw it on espresso. We put it in our portafilter, we put that in the espresso machine and we start brewing. How can espresso allow water to pass through this coffee much faster than this? That's why espresso has 9 bars of pressure. Espresso means expressed, which is in Italian, which is implying pressed out. So when you take a fine grind like this, which would normally at normal gravity and water pressure very slowly drain, you take that, you put it in the portafilter, you apply pressure. Under that pressure, the water passes through the beans very quickly, which allows us within 25 to 30 seconds to extract the flavor that we want out of these coarse or out of these very fine grinds and get a full extraction. So let's come out of that hole and we'll come back to that later, but keep those thoughts in mind about grind size and how it works, how coarser grinds are going to allow water to pass through more quickly and finer grinds are going to stop the water from going nearly as fast. Think about how at a finer grind, pouring hot water over it will extract the flavor out much faster out of the actual bean because it's so small. And how at a coarser grind, pouring hot water over it will take longer to extract the flavor out. Mixing those two variables is how you start to extract consistently. And as we get into extraction, we're going to talk about what's the happy medium. What's the balance between the right grind size that the water is extracting it at a good pace and flowing through it at a good pace. We're going to talk about, But to get into that, to understand more of what's going on, we have to dive a little bit more into the weeds before we can come out and say, it makes total sense. So while these are starting to feel a little bit more complicated, I think diving a little deeper is actually going to make this feel a lot lighter. So let's go ahead and move into the 3 keys of brewing: time, temperature, and action, and how those 3 keys, working with grind size, will allow you to have complete control over your cup of coffee. Coffee. So we talked about that waterfall. We talked about how water running through sand versus running through boulders, how it's a very big difference. That's super real, but that's not straight up applicable. That's not a coffee maker. So we have an illustration that kind of highlights that, what's going on. Essentially what you're looking at is, let's say we've got a V60 like this, right? You got the V60 and you've got the kettle over here pouring water over it and it's pouring into the cup and you've got huge chunks in the cup. Boop, 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 boop. It's filled with huge chunks, just rocks. And you start pouring water over that V60. What's gonna happen is that water's just gonna run right through it. And the water's just gonna pour out the bottom. If this had huge chunks, imagine huge chunks just filling this up, water's just gonna come pouring out the bottom, no problem, it's gonna run right through it. On the flip side though, if I were to take this V60 and I were to fill it up with tiny specks of sand, just thousands of pieces of sand, and I started pouring water over it, the VCC is going to fill up to the top really fast and just drip out the bottom. That's essentially what's going on anytime we're adjusting grind size. That's going to be super helpful whenever you're doing espresso and you have a shot that is sour tasting. And we're going to talk about that, what to do when it's sour, in just a moment. But whenever it's sour and the shot's pulling at 20 seconds and your goal is, with this coffee, let's say it's 25 seconds, and it's sour and it's off and the water's running through it super quickly. Well, now you know, oh, this grind size is probably too coarse, meaning the chunks are too big and the water's running through it too quickly. So let me make it finer. Let me adjust it in that way. If I make it finer, it's going to slow down the brewing. It's going to allow the water to sit with the coffee longer and extract a little bit slower so that the water is going to come out at a good pace and we're going to have more of the coffee extracted. Now, it might take 25 seconds to brew that shot. That's maybe still pulling the same amount of water in the end. And it's going to be a much more balanced shot of espresso. That's something to be thinking about and chewing on. And we're going to apply that momentarily with some more pour over illustration. But for now, keep that locked in. We're going to move on to the keys of brewing. All right, so we've talked about quality. We've talked about water quality and coffee quality. And we've talked about ratio differences in grind size. How much coffee, how much water, why the grind size matters, and how you pick that. We've dove into those things, and now that we have a pretty good level of understanding of how those function, the last three things we're going to hit on, the three keys to brewing, are time, temperature, and action. Action could also be described as pressure or turbulence, agitation. I've heard it described as a number of things. Essentially, what we're saying is that the amount of time that the coffee is interacting with water and brewing matters. The temperature at which that water is that is interacting with the coffee, and the coffee therefore as well, matters. And the amount that the coffee is either put under pressure or stirred or agitated during the process of brewing matters for brewing. So let's talk about how those three work together. For now, I'm going to go ahead and start brewing a little cup of coffee. It's going to kind of be our standard. We're going to use just a kind of a very similar to what a standard cupping would be, except we're going to shrink it down and we're not going to go through the whole procedure. We're just going to use a very simple method where I'm just going to put some beans in, or put some ground coffee in. 5 grams is what I'm going to do to this. I'm going to fill the cup up, and then we're going to, after about 4 minutes, I'll taste it. So that's going to be our base. That's going to be our standard recipe for what we're doing right now. The temperature of the water is about 195 degrees Fahrenheit, and that's going to be true for this cup right here that's already brewing. The water I put in was at 195. Same thing for this one. I'm going to put in 5 grams of coffee. And then I put a little more, but that's all right. And then we're going to fill this up with water. Let's start the timer. That's going to be our base, 4 minutes. You'll notice one thing that's missing from this brew method is filtration. And that is absolutely true. This is going to be a little bit more gritty, but I'm going to stir it at a certain point and let the grind settle, and it'll be all right. The point here is the illustration. So what we're looking at is, I've got a cup that started brewing 5 minutes ago. This guy's been brewing for a while. I've got this cup here that we just started brewing. At 4 minutes, we're going to finish that extraction. And then I've got another cup here that we're going to brew a little differently, and then another one here that we're going to brew differently. What we're going to highlight is all three of these things together: time, temperature, and action. So for this first one, what's happening is that I put this coffee ground up the same grind size in all of these, the same water in all of these, the same coffee in all of these. All of our variables are the same ratio, everything's standard. For this first cup though, what I changed is that the temperature is not 195 degrees Fahrenheit and the time is longer. For this cup, what we're going to do is we're going to take the same 5 grams of coffee, same water, everything the same, everything standard, but we're going to do cold water. And we're going to do gross water, just for fun. And then on this one, this will be our base, same coffee, same everything, same ratio, and we're going to do a standard 4 minutes. This one, we're going to do the same thing, same standard 4 minutes, same coffee, everything. It's probably getting redundant at this point. But what we're going to change on this one, we're going to keep it 195 degrees. We're going to put it under pressure, and we're going to push the coffee through it. And we're going to talk about what each of these is doing, what's happening to each of these coffees, and how they're extracting differently. For this one, we're going to illustrate what happens with cold water. So let me go get a piece of equipment. Cold brew. Here's how you cold brew. Just kidding. That is how we cold brew at the shop when we're doing big batches of cold brew. But it's probably not how you're cold brewing every day. You're probably not making 30 gallons on your daily. You might be making something smaller, something in a jar, something in a little bucket. For this example, we're going to use this little baby cup. Now, a good possible trivia question with cold brew is how long on average do you think that cold brew should be brewed for? On average, we say that cold brew should be brewed for anywhere between 18 to 22 hours. Now, that totally could depend. Sometimes you're going to brew it, you might toss it in the fridge and brew it for 24 hours. Why? Because temperature affects brewing. So let's go ahead and dive straight into that, how that works. For now, we're just going to take this cold brew. We're going to set it over here to mark that this is the one that's brewing cold. And whenever that's ready, we'll get to it. But that won't be today. Then we've got our long brewing batch. This guy's been brewing for 10 minutes, and this guy's been brewing for about 4. So I'm going to go ahead and stir this guy so that it can be tasted. Go ahead and rinse it off. I'm going to stir this guy too. What I'm doing right now, just because of the sake of the way that I'm brewing this, I'm just stirring it so that the beans, the grinds that are kind of floating on top, settle down so that I can scoop off the top and taste the coffees. It also is going to slow the brewing. Ooh, I shouldn't have done it. It's also going to slow the brewing because now that the beans are no longer up in the air, all being affected by the water very actively, they've settled down to the bottom. It's going to slow the brewing process, but it's going to keep brewing. Finally, let's go ahead and start the AeroPress. This guy is an AeroPress. I'm going to go ahead and rinse. There's a little paper filter in the bottom of it. I'm just going to go ahead and rinse that paper filter. Across the board in any brew method, it's a great idea to rinse your paper filters. It's going to get any chemicalness out of the paper. It's going to get the paper flavor out of the paper. So if there was bleached paper, it's going to wash that out. If it just is natural paper, natural colored, all that, but it still has a paper flavor, you're going to get that out. You're also going to help preheat your mug. So now we're going to put 5 grams of coffee in this. We're going to do the same amount of coffee as we did in these. And then we're just going to get this brewing. While that's brewing over here, let's talk about time, temperature, and agitation. Each of these deviated from one of those in some capacity. So let's talk about how each of these cups focused on time, temperature, and agitation in different ways. Off the bat, we've got our base cup of coffee. The time on this cup of coffee for brewing is about 4 minutes. The temperature is 195 degrees Fahrenheit. And the only agitation or action or pressure, in this situation, agitation, that it experienced was a gentle stirring to get the beans and the grinds to kind of settle. This next cup was our long time cup, or our long brewed cup. It's currently sitting at about 13 minutes on the timer. This guy started brewing 5 minutes before this one. It's been brewing for a really long time. This guy hasn't been brewing any longer than this one. It's the same standard. It's about to reach 4 minutes. We're not quite there yet. This guy is going to have the same amount of agitation as the other cups. Whenever I stir it, it's going to get 1 stir and that's going to be it. But what's different about this cup is that it is cold water. It's not hot, so the temperature is not the same. And then this last guy right here, once he hits 4 minutes, I'm going to take this, I'm going to set it on top, and I'm going to plunge the water through. We're going to put a lot of pressure on that coffee. That's the action in this situation. We're going to put pressure on it. So the temperature is the same. The time that it's brewing is going to be the same, but there's going to be pressure. What's going to happen? What's going to be the difference? Why are these going to taste different and brew differently? Why does that matter? Well, it's important to begin to understand how these things interact because different brew methods have different flavor profiles and different things, and there's reasons for that. So, for example, why does a French press, where the coffee sits with the water for 5 to 8 minutes maybe, taste different? and extract different and have different capacities than espresso, which is a lot of coffee, a very small amount of water, brewed at the same temperature maybe as a French press, but over way less time with a lot more pressure. We're reaching about 4 minutes on the cold brew, so I'm gonna go ahead and stir that. Just so we get a taste of what's going on, or just to keep consistency. And as we reach 4 minutes on the AeroPress, I'm gonna go ahead and plunge it with pressure. We'll dive into espresso later and do some more pressure stuff, so we'll get some more on this, but this is just a great little example piece. So notice that I'm putting pressure under this. This is pushing the water through those grinds there at the bottom of the AeroPress, causing it to brew and extract very rapidly. And now we've got our coffee in this cup. 4 cups laid out in front of you. 1, 2, 3, 4. You can probably already assume off the bat some of the principles that we're going to talk about here. So for example, if I'm cooking something and I cook it longer, it's going to cook more. That's true with coffee too. And as opposed to just cooking or burning, whatever, we call that extraction. We're going to dive more into extraction momentarily, but we're starting right now. So that's extraction. Extraction is as soon as the water hits the coffee, stuff starts coming out of that coffee. It's extracting at this point. What we're looking for always is a well-extracted cup, what you might call a well-balanced cup of coffee. If it's under-extracted, it didn't get extracted enough, and if it's over, same thing there. So with time, let's assume that all the other variables are figured out. Let's say our goal is the 4-minute cup of coffee, and we just brew it for 2 minutes and start drinking it. Well, while we can talk about momentarily what the flavors that we're gonna get are, what we know is that that cup is under-extracted. And if someone comes to you and says the perfect recipe for this cup is 4 minutes, and you brew it for 6 minutes, or for 10 minutes, or for in this case, 16 minutes at this point, you know that that is going to be an over-extracted cup of coffee, which will in turn taste bitter. And we're gonna hit on that momentarily. So that's the basic premise with time. Our goal is to find the time that extracts the coffee well. But you can't just have time alone. You have to be paying attention to the other variables involved. So what are those variables? What's going on? Well, we already know with time that the brew method makes a difference, right? The brew method, whether it's espresso, you're going to for a faster time, pour over maybe slower, French press even slower, cold brew, hours and hours to brew your coffee. There's a reason that those methods brew differently, and that's because each brew method has a different way that it interacts with time as well as temperature and action. So let's go to the next step, temperature. What's going on with temperature? Well, just like when you're cooking something, or let's say you have tea and you want to dissolve tea into water. If you put tea into cold water and start extracting it, it's really not going to brew the tea. But if you use hot water, it's going to extract the tea. Same premise, makes sense with coffee. One other example, let's use that example. One example that may be very helpful, and that was helpful for me in understanding how coffee dissolves at different temperatures. While it doesn't perfectly translate, is very similar, is simply putting sugar into a beverage. So if you've ever made sweet tea, or you've ever made some sort of sugared drink, if you pour sugar into a cold liquid, some of it will dissolve into the liquid, but not all of it. But if you heat up that liquid and pour the sugar in, that sugar is going to dissolve much more easily into that liquid. And that's because temperature speeds up extraction. Things are moving quicker, things can dissolve better. Same premise with coffee. So at a hotter temperature, which the 212 being the highest temperature we can truly brew at, because that's where water evaporates unless we're keeping it in some sort of pressurized unit. But even then, by the time it's reaching the open air, anything over 212 degrees is going to evaporate. So with our cap at 212 degrees Fahrenheit or 100 degrees Celsius, what we're looking at is the higher the temperature, the faster that coffee is going to extract. So for example, let's say we have the same cup and our goal is a 4-minute brew of coffee at 195 degrees Fahrenheit. And the person that hands it to you says, this is the perfect recipe for this coffee, which is not true. There's no perfect recipe for any coffee, but maybe what they're giving you is a very good recipe. So let's say they give you that. 4 minutes, do 4 minutes, 195 degrees Fahrenheit, and they give you all the rest of it. They give you the ratio, the grind size, all these things, and you have it all locked in. You have the water quality, you got it all down. And so your only goal is to focus on 195 degrees Fahrenheit, 4 minutes. And you boil your water. You do 212 degrees Fahrenheit and you think that's not going to make a difference and you pour it in. Well, it is. What's going to happen is you're just like if we brewed it for too long, it would get over extracted. If it's too hot at that temperature, it's going to begin to get over extracted as well. Now, the general rule of thumb, and this is really, really helpful, is to say that you should brew your coffee between 195 and 205 degrees Fahrenheit. Anything under 195 degrees Fahrenheit is going to almost consistently under extract your coffee. Now, there are ways around that, and there are certain ways that you can brew and experiment where you can get a well-extracted cup underneath 195, but 195 degrees Fahrenheit is a great rule of thumb for the bottom barrier. Always be at least 195 degrees Fahrenheit when brewing your coffee, and try not to reach much over 205. Now, the higher density the coffee is, or sometimes coffees that are more lightly roasted, they can handle temperatures that go past 205, and that's great. And I totally recommend experimenting with that and trying out coffees at different things, at different heats and different temperatures. Typically, the lighter the roast, the higher the temperature it can withstand, and the darker roast, the lower temperature it can withstand. But as a rule of thumb, most coffee is safe between 195 and 205 degrees Fahrenheit. So, to use the counterexample, just to, what's the beat the dead? I don't even remember the metaphor.
Beat a dead horse.
Beat a dead horse. Just to don't go beating any dead horses. On the flip side, just to use a metaphor, on the flip side, if you were to take this coffee and pour cool water in and only brew it for 4 minutes, like this cold brew right here, if we only brewed this for this amount of time, for maybe 10 minutes now, and we tried to drink it, it would be severely under extracted. Without the heat to dissolve the coffee bean, it's not going to extract nearly as quickly, and it's going to need more time. The cooler the water, the more time it's going to need. Time for a tangent. Why do we not want to brew water under 195 degrees Fahrenheit? I mean, when we brew cold brew, we brew it at room temperature, and we brew it for so many hours. Why not just say, as you get less than 195, just keep increasing your time that you brew, and those will kind of even out. Less temperature, more time, good brewing, good extraction. There is some truth in that, and there is some accuracy there. But what we have to keep in mind is that what's happening in cold brew and what's happening in regular hot coffee is actually quite different. So above 195 degrees Fahrenheit, there are parts of the coffee that are dissolving because of the hot water, right? So because you're pouring boiling water or near boiling water over the coffee, there are all these things that will dissolve due to the heat. But when you start to cross a little under that 195 degree Fahrenheit realm, especially as you get below 190, 185, as you get down there, you're starting to not dissolve things out of the coffee bean that are desirable, that you do not want to lose most of the time. So as you start to get to those lower temperatures, because of the lack of heat, certain things simply will not extract into your cup, which is why 195 is typically the threshold for hot coffee. Which leads to the question, why cold brew then? What's going on? Cold brew is different. It is a different drink. It's a different creation, but we have found at Joe that it has a really, really good place. So cold brew, while not extracting all of the same flavor profile that hot coffee does extract a very good drink. So let's say we take a cold brew room temperature for like 18 hours. Well, we may not get all of the complexity of the flavors that we might get from a pour over that takes a few minutes. We may not get as much vividness in the flavor. What we are going to get is this really nice, fully caffeinated, the caffeine is present, really nice, smooth textured drink that tastes very similar to hot coffee, but with its own unique twist and flavor. If you haven't had cold brew, I recommend you try it. Or if you haven't tried cold brew in a latte, try it in a latte. Because what's something that's really neat about cold brew, especially if it's with beans that are paired well for cold brew, certain beans, acidic beans, and really dark roasted beans don't go well with cold brew. But for example, like our brewski blend that we have, it's a medium roasted Brazil with a pinch of with a light roasted Ethiopia, or a more modern roasted Ethiopia for some sweetness and some chocolatiness from the Brazil. That's our goal. When you cold brew that and you could mix that with milk and you add maybe sugar to it or some sort of make a latte out of it, or just have it with milk, it's this really smooth, creamy, delightful drink that, because it was cold brew, misses a lot of the bitterness that you might get if you take espresso and ice it in an iced latte. So specifically for iced lattes, it can make a killer concoction, a killer base for all kinds of mixed drinks. So that's why we love it. We get to have a lot of fun with cold brewed drinks at Joe Brewski, which is why we have dug so far into cold brew. If you haven't experimented with it, I totally recommend it. We also offer cold brew kits and things like that. So if you wanted to sample stuff out, reach out or buy one online. But we have some more options that are online sometimes that we can work with you. So just let us know. It's really fun to see people get into cold brew. So try it out. But that's what's different about cold brew. And there's also just a lot to experiment with there. Whenever we have a really fruity coffee, we will actually take it and we'll often put it in the fridge and we'll let the water cool to about 40 degrees or whatever the fridge is at. And then we'll do the cold brew from there, and we'll brew it for about 24 hours. And it's kind of crazy when you slow down the extraction like that on some of these fruitier coffees like our Ethiopia. You might get a really fruity tasting cold brew that you would never expect from something brewed so differently than hot coffee. But it really can happen. There's a lot to experiment with there. So cold brew is a fun one, as you can see, but I'm getting kind of passionate about it. It's a really fun drink. But for now, we're going to continue talking about extraction across the board. So back into it. These drinks are ready to give them a try. So first, let's just try the base coffee. See where we're at. This is our Spro blend. I'm just gonna go ahead and give it a taste. Don't mind my slurping. Slurping is a common custom whenever you're cupping and tasting coffees. I'm splattering the coffee all over my mouth to taste it. I highly recommend doing that at your own cafe if you're tasting a number of coffees side by side. If you never tasted coffee side by side, please do. It'll expand your palate and help you understand what you're tasting. And slurp. Just let people know that you're gonna slurp. So this coffee tastes great. It tastes balanced. It's good. It's a smooth cup. Of course, it's not super filtered, so there's a little bit more grit to this cup, but the flavor is good. It's been brewing at a good time. 4 minutes, 195 degrees Fahrenheit. It's great. This next cup has been brewing and agitated and been brewing for about 10 minutes now. So let me go ahead and try this. And that one is much more bitter. It's certainly over extracted. It's not exactly desirable. It's also cooling down, so the flavors are much more present. Your mouth can taste flavors a lot more as things cool. So, which is why if you take a boiling cup of coffee and you taste it, it might just taste like other coffees, but as you let it cool, you're gonna taste a lot more flavor. So if you're tasting coffees, always let it cool before you fully drink the cup, even if you like your coffee really hot. But yeah, so this guy is really bitter. I probably won't take too many more sips of that one. It's not ideal. Now this cup right here was the same as the base method. It has been filtered, but at the end of 4 minutes, I didn't put a normal amount of pressure on it. I really pushed pressure through it. So I really agitated those beans. So everything else about the recipe was the same, but I really agitated the grinds as I pushed them through. So what I'm expecting is a different kind of over extraction here. It's not just that it brewed too long, but that the beans were pushed after they had already been brewing for a number of minutes. And what I get is not the worst cup in the world, but you start to get these really volatile flavors that after coffee's been brewing for a number of minutes, the more that it gets shaken, the more that it gets pushed, the more volatile it is, and the more likely it is to release undesirable flavors into your cup. Which is why at the end of brewing cold brew, you have to be careful not to just shake the bag a bunch when you pull it out of your cold brew. You want to gently pull it out and let it drip gently before you throw it away. Because agitating the beans after they've been brewing for that long can really lead to some undesirable volatile flavors getting into your cup. So that's what I'm experiencing in here. It was almost extracted well, but because of the pressure I put on the beans, the action that they went under, this cup is over extracted and not desirable. And then finally, here's our cold brew, which should steep for another like 18 hours and isn't going to. And it's gonna have beans in the top, but I'm still gonna go ahead and try it. It's gonna be gritty, it's gonna be gross. And it tastes like gritty water with mud in it. So don't do that. Let your cold brew for the full time. We'll set it aside and come back to it, maybe. So let's recap. That was a whole mouthful, a whole lot of things, a lot to look at. What did we just go through? Time, temperature, and action. How do these all work together? The amount of time that something brews for matters because the longer it brews, the more that the coffee is going to extract. The temperature matters because essentially the hotter the water, the more the coffee is going to extract, which is why whenever we say we cold brew coffee in a fridge for 24 hours or at room temperature for 18, that difference happens because the colder it is, the slower it extracts. And then finally, action matters. How much the coffee is stirred or pressed or put under pressure, which all do different things, but essentially are summed up under action. How much the coffee is touched and affected really matters for extraction. The more that it is stirred, touched, acted upon, the more it's going to extract. So our goal, always when brewing, is to find the right balance of time, temperature, and action. With this base knowledge of how time, temperature, and action work together, what I would do if I were you is start looking around at the different brew methods that you have at your cafe or that you're thinking about doing or that you've seen, whether it's espresso, drip coffee, pour over, whatever it is, French press, you name it. If you have certain methods that you like, that you found that you like, or that you have no clue about, look into them, Google them. We'll attach a sheet with a few, I think we already said we would, with a few coffees, ways to brew them, and certain recipes that include the ratios and everything like that. Essentially what we'll do is we'll break down all 8 of the variables for a number of brew methods so that you can have a set recipe that may not be the perfect recipe for your coffee, but is gonna be a good starting ground. But what I would do is check that out, but also go look around, read different people's recipes, and pay attention. Start asking questions like, if the time on espresso is only 25 seconds, but the grind is really fine, so it's gonna extract faster, and the temperature is about 195 degrees Fahrenheit, and the pressure is really high, why does this brew method happen so fast? And the answer would simply be, well, since the grind size is fine, it extracts quickly, and because it's under a heavy amount of pressure, it can extract even faster. So add that to hot water, you only need about 25 seconds to brew that coffee. Then you might ask the question, why does a French press take, for say the recipe is 6 minutes, why does that take 6 minutes? Well, a French press is not being agitated once it starts brewing. You just let it sit with the water and then you pour it. The temperature is hot, it's 195, but your grind size is usually coarser. Oh, okay. So it needs time to extract, so we use a coarser grind. But we're not gonna give it much action. It's not gonna be stirred, it's not gonna be pressed under a lot of pressure, even though it's gonna have a gentle press at the end. So it should take more time to brew to get an equal level of extraction. Okay, those kinds of things are gonna start adding up more and more and more. But what we wanna dive into next is with across the board, whether it's a small little cup or a big cup, how does extraction work? What is happening? What flavors are coming out when I'm extracting? How can a cup this big and a cup this big, albeit brewed differently, have the same balance of extraction? Even if this one's stronger and this one's lighter, how can they have the same balance of extraction? If that doesn't make any sense to you, don't worry, we're gonna dive right into it. So the question that we're beginning to ask is, how can a small cup that we've brewed well and is now well balanced have a similar extraction to a big cup that we've brewed well and is now well balanced? How can these, though with different recipes, still have the same or very similar extraction yield? Well, don't worry about it too much yet. Hold on to that phrase, extraction yield or extraction level, because we're gonna revisit that and all the pieces are gonna start fitting together. At this point, we have covered all of the 8 variables of brewing. You've got your 2 for quality, water quality and coffee quality. Be intentional about the water you choose, be intentional about the coffee you choose. Then we went into ratio differences and grind sizes. Pay attention to how much coffee you're using and how much water you're using depending on the brew method, and the grind size depending on the brew method of what you're doing. Finally, we hit on the 3 keys to brewing: time, temperature, and action. The amount of time that coffee brews for is crucial to its extraction. Same thing with temperature, and same thing with action. Understanding how all 8 of these variables begin to work together will continue to improve your coffee game for the long run. In time, things will make sense. Things will become more cemented. You'll know that for a pour over, we use this much coffee and this much water. You'll have a set standard for what your coffee quality is or what coffee you're gonna use. You're gonna have a standard for your water. You're gonna have a standard ratio, and the grind size is gonna be figured out. You're not gonna have to think about nearly as many factors. You just look up a couple recipes, use some of the recipes we'll send your way, dial it in, and once it's dialed in, all you're really thinking about is your time, temperature, and your action, and making sure those things are locked in. So you'll be set, you'll be good. This is all gonna come into place. But now you have the pieces that you need to bring them together and begin to understand more and more over time as you brew coffee, as you practice, as you serve people their coffee, how to improve and how to work with the quality of your coffee.